In this video, we're going to do still another example of finding the surface area of a solid of revolution. So in this case, we are going to generate our surface by taking the curve y equals x cubed over 6 plus 1 over 2x on the interval from 1/2 to 1 for the x's about the x-axis. So again, our surface area formula is 2 pi integral from a to b of y ds. In this case, we're given a function of x, so we replace the y with that function of x, with that x cubed over 6 plus 1 over 2x. The derivative of y in this case is 1/2 x squared minus a 1 over 2x to 1 over 2x squared. We're going to square the derivative, add 1, and take the square root. That is the differential for the arc length. This is going to look a lot like those arc length problems now, where we have to multiply out, simplify, and refactor. Notice when you multiply out, you're going to get, when you take the x squared over 2 times the 1 over 2x squared, you get a minus 1/4, and you have to do that twice. So that's where the minus 1/2 is coming from when you distribute. We get an x to the 4th over 4. When we square the x squared over 2, we get a plus 1 over 4x to the 4th when we square the 1 over 2x squared. When we add the 1 and the minus 1/2, we get a plus 1/2. And again, notice that this expression we have is almost identical to the expression we got when we multiplied out that squaring. It's just that the sign in the middle has changed. So when we refactor, we get almost exactly the same thing. It's just that the sign in the middle has been changed. So under the square root, when we refactor, we get x squared over 2 plus 1 over 2x squared, that quantity squared. The square root and the square will cancel each other out, so we now have in our integrand of x cubed over 6 plus 1 over 2x times x squared over 2 plus 1 over 2x. Distribute all of that out, we get x to the 5th over 12 plus x over 3 plus 1 over 4x cubed. And remember, we're integrating this over the interval from 1 to 1/2. So finally, we get to a point where we do some calculus. We've had lots of steps of algebra. Finally, we're going to do an antiderivative. 1/72 x to the 6th, 1/6 x squared, 1 over 8x squared. Those are your antiderivative piece by piece there. Plug in your endpoints and simplify the arithmetic, and you should end up with 263 pi over 256.